Okay, so we have completed Poisson's ratio and then we have completed the elastic potential energy in a stressed wire, and then we have solved some numerical on Young's modulus, rigidity modulus and bulk modulus. Okay. So now we'll cover some, even though it is more theoretical in nature, I'll try to uh, I'll try to highlight some of the key features of applications of elastic behaviors of materials. Okay, so the elastic behavior of material, uh, it plays an uh, important role in everyday life. All engineering designs require proper knowledge of elastic behavior of material. Like for every engineering design, when you are building a structure, you need to know what is the strength of the material, what is the Young's modulus of the material. Without knowing that, you cannot design any structure. Okay, so that's the reason. For example, while designing a building, the structure design for the columns, beams, and supports require knowledge of strength of materials used. Okay, so for example, you have a building. Okay, so your building will have columns and it will have beams. Okay, so the columns are the vertical member and the beams are uh, the horizontal members. Okay, so you have columns like this and you have beams like this in a building. Okay, so so uh, so when you see that, suppose this is your roof or whatever. So let us say this is your foundation or whatever. Okay, so this is your column, right? This is your column. The vertical members are called columns, whereas the horizontal member in the perpendicular to the plane also there will be beams. Okay, what you can see is only the one section you are able to see here. So any building, so the horizontal members will be your beams. Okay, so these are beams and the vertical members are called your columns, right? So to uh, construct a beam, so these columns will be made of concrete plus some steel. Okay, so you need to know, like, what is the strength of this concrete. Okay, suppose the building will carry certain load. Okay, so like the load of itself weights. Are you concentrating?
Yes. শোনো শোনো
I'll ask. I'll ask you about building. Which type of load a beam takes?
the perpendicular one.
Which is the vertical member is the beam or the vertical?
No, the horizontal is beam, vertical is column.
Okay. So don't sit here and think something else.
No.
That is not going to work actually. So the horizontal members are beam. Okay. The vertical members are your column. Okay. So the column is made of concrete plus steel. Okay. So to any building design, you need to know what the structural material, what it is made of. Okay. So if it is made of concrete plus steel, then what is the strength of that? Like this column, what kind of load it is taking? So if you take a free body, it is taking some kind of compressive load. Okay, right? So you just remove that top beams from it. What kind of load it is coming? It is taking some compressive load. Say what kind of weight actually will be in on the building? The self weight of the roof, right? And also you will be designing for, suppose you want to you are going to build some other story on this building in future. So what kind of load this is going to carry? That you know that, okay, this much is the load it is going to carry. Let us say it is say 1000 kilonewton load it is going to carry. So you imagine that there are 4 columns. Okay, so that means for each column 250 kilonewton load will come on each column. Okay, so if I know the cross-sectional area of this column, let us say this is circular, say pi by 4 d square. So I can find out what is my compressive stress, which is nothing but 250 kilonewton by the area. Okay. So if this compressive stress is more than the compressive strength, if it is more than the compressive strength, means compressive strength,
Then it can be.
then it is going to fail. The column cannot take more
That much
load
amount.
there. Okay. So why do you put steel? Why not concrete and cement only? Because steel is much more stronger than than concrete. So by putting steel, that is called reinforcement. Okay, reinforcement. So you are reinforcing the concrete by some steel rods. Okay.
Yes.
So if you take a cross section, how it will look like? So it may be something like this. So you will have some kind of concrete, and in between you will have steel rods. Okay, you will have steel rods, few steel rods. That will increase the strength of this. Okay, so this will increase the strength of the column. Okay,
Yes.
the similar principle is being used for composite materials. Like you will have resins and you will have some fibers.
Okay.
So you might have seen that nowadays a lot of composite materials are being used where the strength of the fiber is much higher, much more higher than that of the resin or the binding material or whatever. So so that's why, so for building so for doing a building design, we need to know what is the strength of the material, what is the Young's modulus of the material. All those things you should know. Otherwise, you cannot build a building. Okay. So, for example, while designing a building, the structural design of column, beams, supports require knowledge of strength of material used. Have you ever thought why the beams used in construction of bridges, I support, etc., have a cross section of type Y? Why does a heap of sand or hill have a pyramid shape? Answer to these questions can be obtained from the study of structural engineering, which is based on concept developed here. Okay. So the question he is asking: have you ever thought why the why the why the beams used in construction of bridges have a cross section type I? Okay. So what happens actually? So normally this is a building. So they are likewise. You might have seen a bridge.
Bridge.
In civil engineering. They do the study. So this is one side of the river. This is another side of the river. So in between you will have so many supports. You will have so many supports in between. Okay.
Yes.
So this support sometimes, if you take the cross section, this support may not be a square or rectangular in nature. This support can be of I cross section. Okay. So the support can be of I cross section. So why do we need a I cross section? That we will discuss.
Okay.
Like why I cross section is required. So that comes the moment of inertia concept. So that I'll explain. And then there are some questions. Why does a heap of sand or a hill have a pyramidal shape? So heap of sand, why it looks like a pyramid? Why a hill looks like a pyramid? What is the reason behind it? So those things also we'll discuss. So answers to these questions can be obtained from the study of structural engineering, which is based on concept developed here. Okay. So these are all for structural engineering. You need to know the elastic behavior of the material. Okay. So so you can take a picture of it and we'll study about cranes. Okay. So why cranes are being used. So we had recently visited Paradip port and all. Lot of cranes are being used there. They like to move heavy materials, heavy components from one place to the another. There will be lot of cranes that are being used. Okay. So we'll discuss about cranes. Cranes are used for some heavy lifting job, right?
Yes.
You want to like I have worked in HL. Okay, there we used to work for we used to manufacture engine. Okay, So that engine is of like say 1200 1300 kg weight. Okay, so that kind of weight. So you imagine 1 quintal means 1 quintal of rice, one big bag of rice is 1 quintal, which is 100 kg. But this engine is of let us say 1200 kg or so. So that kind of weight a crane can carry, that kind of weight, huge weight. So how does a crane carry? Suppose you want to move the engine from one location to another location. So that crane will be hanging from a rope. That rope will be connected to a pulley. That pulley will be driven by a motor, and it will move from one place to another. So that's how it is. So the discussion is like this. So cranes are used for lifting and moving heavy loads from one place to another, and have a thick metal rope to which the load is attached. Okay. So let us say my I have some kind of like say let's say so this is my, let us say this is my crane. Okay, so this is my crane hook. Okay, so let us see. So this is okay. So let us say this is my crane hook. Okay, so on this crane, so let me say there is some kind of rope is there. Okay, so so let us say there is some kind of rope. Okay, so this is a metallic crane and there is some kind of rope. Okay, and this rope again it will be hanging from some pulley kind of thing. So this is my pulley. Okay, so actually this rope will be hanging from this pulley. It will be from here actually. Okay, so the pulley will have the rope will be hanging from the pulley. Okay, so let me draw it.
Inside that.
Mm-hmm. So this is hanging. So my rope is like this. So my rope is like this, and let us say this is my pulley, right?
Yes.
So this pulley will have a groove, and this pulley will have a groove. This is the center, and this is my rope. Okay, right?
Yes.
So this is called my pulley, right? You might have done many numericals related on pulley in your statics. Okay, so this is your pulley, this is your rope, this is your rope, and this is your crane hook actually. This is crane hook. So the complete system is called crane. Okay.
Yes.
So this this rope is being operated by a motor. Okay. So you will have some handheld buttons, move forward, move up, move down.
Okay.
So you will have a handheld device. It will have different switches, 1, 2, 3, 4. So here you will press it. It will be given like this. Move left or right.
Okay.
So left, right. Okay. Then it is
Up,
like
down.
up, down, like this. So with this you will operate it. So the motor, that motor will the motor will make this crane lifting up, lifting down, moving left, right. So it will move left, right. It will go up, down. So whatever you want to do, you can do with the help of a motor. So all that you need electrical energy. Okay. So that is the function of a crane. You see many cranes in all the industry, most of the industry. But the main aim is to move heavy loads. The function is to move heavy loads from one place to another. That is the function of crane. Okay. So the crane will have a hook. Okay. So we will solve some. Suppose we want to make a crane which has a lifting capacity of 10 tons. Okay. 10 tons. Okay. So lifting capacity. Okay. How much it can lift?
Maximum.
Lifting capacity is equal to 10 tons. Okay. 10 tons. Okay. So 10 ton means 1 quintal.
Is 100 kg.
1 quintal is 100 kg. 1 ton is 1000 kg. 1000 kg. then 10 ton is 10,000 kg. 10,000 kg. Okay. So the 10,000 kg. So that is the lifting capacity of.
A crane.
Okay. Okay. 1 metric ton. Okay. So 10,000 kg. How thick should be the rope be? So so this rope, I am just putting this rope as one line, but actually if you take the cross
It will be
section,
very thick.
it will be a thick rope. Okay, it will be a thick rope. So how thick the rope should be?
Dimension.
Okay. So what thick means, what is the diameter of the rope? That is the question. How thick the rope should be?
Carry 1,000 kg.
So the rope is made of steel. So the rope is made of steel rope.
Okay.
Steel braids and steel rope. So how thick it should be? So that is the question. We obviously want the load does not deform the rope permanently. So we don't want the rope to get deformed. Otherwise it will get elongated and it will break. We don't want. So we don't. It should remain elastic. It should not cross the life proportional limit. Okay. So load to deform permanent. Therefore, the extension should not exceed the elastic limit. Okay. So you know there is a proportional limit and there is a elastic limit. So it should not exceed the elastic limit. Means there should not be any permanent deformation. Okay. So we have done the proportional limit, then elastic limit,
Ultimate
then the
tensile.
yield.
Then yield point, then ultimate tensile strength.
Yeah. So it should not cross the elastic limit. Okay. So from table 9.1 we find that the Young's modulus, we find that mild steel has a strength of about 300 into 10 to the 6 Newton per meter square. So this steel is made of this rope is made of steel whose strength, so it should not exceed the yield strength. So yield strength is 300 Newton per mm square. Okay, right?
Yes.
300 MPa, that is the strength of this steel. Okay. Okay, so it should carry 10 tons. Okay. So my question is what is the stress actually? This is force into area. So this is actually strength. Okay, strength is properties of the material. Stress is applied. So applied should not exceed the properties of the. It should not. So it is properties. So this is allowable. So applied should not be more than allowable. Okay. Okay. So what is applied stress? So it is force is nothing but your 10 tons. So 10 into 10 to the power 3 kg. Okay. Then we know force is equal to mass into acceleration.
Yes.
So this is mass only.
Now
We have not multiplied acceleration. So you consider it as 10 meter per second square. Okay. So this. Okay. So this 10, then your area is nothing but your pi by 4 d square. Okay. So pi by 4 d square.
That we should
So
find.
this you equate with 300 MPa.
Okay.
300 MPa. 300 Newton.
300 MPa is yield point. The maximum it can be.
Maximum. It should not exceed 300 MPa. Okay. So whatever stress, it should not be more than 300.
Yes.
Okay. So 300 into 10 to the power 6 Newton per meter square. Okay. So this side you have meter, this side you have meter.
Same unit.
So once you solve this equation, this is your homework. Once you solve this equation, you will find the diameter of the rope, and the diameter of the rope, you can find first the area of cross section. Okay. Then you can find the diameter of the rope. Okay. 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 So by solving this, you will find the diameter of the rope to be 1 centimeter. You just solve it and find out how it is 1 centimeter. I am not solving it here. You can solve it. You write down the question and you just write down what is force. Yeah, what is force? Force is 10 tons. That is 10,000 kg. and you know the strength of mild steel is 300 Newton per meter square, 300 Newton per mm square.
Strength.
Strength is 300 Newton per mm square,
Which is 300 MPa.
which is nothing but 300 MPa. So that will become 300 into 10 to the power 6 Newton per meter square. Be careful about this MPa. Mm square is same as MPa, but you have to multiply 10 to the power 6 and then Newton per meter square. So this side Newton, this side Newton.
Yes.
That you have to be very careful. So you solve this and get me the diameter of the rope, which is 1 centimeter.
Yes.
Okay. See, I would say, see this. You can see this marker. Okay. See, this marker diameter is something around 5 mm. Okay.
Yes.
So two this type of marker together will become 10 mm,
1 centimeter.
which may be 1 centimeter. So to get a feel of how much is 1 centimeter, that is required. Okay. So this is how we are finding So this is my pulley, this is my rope, this is my crane.
Understood.
Okay. So there are a lot of numericals on pulley, rope, and crane and all those stuffs. Okay. So this is actually a core beam kind of stuff. Okay. We need not go into that. Okay. So generally a large margin of safety, margin of a factor of 10 is provided. Thus, the thicker rope of radius about 3 cm is recommended. So we are getting 1 cm, but we are putting some factor of safety. So we can make, if the factor of safety is 3, it will become 3 cm. That means that is called factor. So if I make just 1, my factor of safety is almost 0.
Okay.
And there are two things. One is called factor of safety. Okay. So factor of safety is nothing but allowable by applied. Okay. So if my allowable and applied are equal, my factor of safety is 1. But I want to make my factor of safety 3 so that it will never fail. So if I do that, then I have to multiply like in this diameter I will have to
That means
multiply
you are
3.
applying how much is allowed, that is 1, but it should be more than that.
Suppose 1 cm 1. So if I multiply 3, then it will be 3 cm.
Because
that means
for 1 that is the maximum.
so it
you
is
can
3
apply.
times more stronger. My stress will be much less. If I make it 3 times more, my stress, this will be same.
Because at
but my
1
stress will be 100.
Because at 1 the amount that is applied, that is the maximum.
So because
that
my
can be
diameter
applied.
is increasing 3 times, so my stress will come down drastically.
Yes.
It may not be 100.
More
Instead,
amount
it will
of
be
area will be
it will be so instead of 1 square, if the diameter is 3 square, it will become 9.
Yes.
So my stress will be reduced in 3 times, 9 times.
9 square.
9
That's
times.
why.
Yeah. So we introduce some factor of safety in any design. Okay. That depending on that you can do it. Okay.
Yes.
So factor of safety you can impose. Okay. So for factor of safety, what you do, like this stress, you reduce the stress by that amount.
The same amount of force, but more area is given.
Yes. Okay, so you can take a picture of this. So we are done with the crane. A single wire of radius would practically be a rigid rod. Okay, so we are doing for a single wire. So a wire cannot have that kind of radius. Okay, so that is why we are not using a rod. Instead, we are using ropes which are made of number of thin wires. Okay, so it will a rope made of number of thin wires. So it will be a rope. You can see a rope.
Yes.
It will have number of thin steel wires. Okay, wires braided together.
That is a rope.
Yeah, like your hair. You are braiding your each hair to
many
one a
strands.
single one, so that it will have more rigidity and more strength.
Yes.
One single hair you can easily break, but if you braid it into a thicker one, you cannot, and its strength will increase. So that's what. So you, rather than using a single rod of diameter this, better to use
Smaller ones which will make
smaller braided ropes, braided wires, and convert it into a rope and that rope will have diameter 3 cm or whatever.
Instead of using one rope of 3.
Yeah.
One wire.
So actually here it is not exactly 3 cm. 3 factor of safety does not mean that it is 3 cm. What you have to do is, if you are applying a factor of safety 3, that means your the applied stress
Is
will be will be so your factor of safety is allowable by applied. Okay, so your applied can be allowable by factor of safety.
Decreasing stress to make factor of
allowable
safety
by factor of safety. So your allowable is 300. 300 you divided by 3, it become 100.
100.
So in this side you put 100 and find out the diameter.
Understood.
So because this has reduced, your diameter will increase. That's the concept.
Understood.
Okay. So you have taken picture of this.
Yes.
No? Okay. So we are done with the crane. Okay. So for age of manufacture, flexibility and strength. So that's about crane. Okay.
Yes.
So crane, we have discussed about buildings, we have discussed about cranes, and in buildings how we are using beams and columns, and what are the kind of loads that are being applied, considered during designing a building. So all those things we have considered. We have considered industrial application, how to move heavy weights using cranes and all. Okay, so
Yes.
those are the two things. Then we'll move to the next one. Okay. So a bridge has to be designed so that it can withstand the loads of flowing traffic. So you have one side of the river. Okay. So this is one side of your river. This is another side of your river. So you have a bridge. Okay. So you will have traffic. Okay. So you will have moving traffic on the bridge. Okay. So the force it can withstand the loads of flowing traffic. So you will have many supports, intermediate supports. Okay. So it will take the load of the traffic, the force of winds and its own weight.
Yes.
So what are the different load that a bridge carries? Okay. So let us say this is your bridge. So this bridge will have its own weight, right?
That
The
it has
bridge
to
will have its own weight. So loads on the bridge. So own weight
traffic,
plus
air.
traffic weight. So trucks and other heavy vehicles and passengers and all that. So traffic weight. And sometimes the weight of the wind also. Okay, the wind. Suppose you are supporting it here, so there will be some heavy wind blowing. Okay,
Due to the water.
so heavy wind, sometimes it will be blowing heavy wind. So these are, because these are slender members, it can bend also those columns.
Because of wind.
So these are the columns. So these are the intermediate columns in the bridge. So they can take the wind load also. These columns can
Yes.
carry. So these are different types of loads that are being used. So in both the cases, overcoming of the problem of bending of beam under the load is of prime importance. Okay. So what happens? Therefore, similarly, in designs of building, the use of beams and column is very common. Okay, so I was telling, in case of building, you are using these are beam, this is column. Okay.
Yes.
So some similar principle. Okay, beam and column. Here also this. Then in these cases, the bending comes into picture. In both cases, the overcoming of the problem of bending of beam under a load is of prime importance. The beam should not bend too much or break. Let us consider the case of a beam loaded at the center, supported everywhere. Okay. So when you are we are doing a rod problem. Okay, we are doing a rod problem and we are applying a force like this and this, and this is of area of cross section A. This is area of cross section A. So we are getting some sigma equal to F by A, and then we are getting this is equal to like say del L by the original length del L by L. These are all longitudinal problem. Okay.
Yes.
But in case of a beam, the beam is something like this. So it is supported at both ends. But if you are applying some transverse load, okay, not a perpendicular, that not in the direction of the rod, but in a direction perpendicular to it. Suppose I am applying a load like this.
Okay, okay.
If you are applying a load like this beam can bend. Okay, so this can bend like this. So it will bend like this. I am putting an exaggerated picture, it will not bend this much, it can bend like this. So what is a beam? A beam which takes perpendicular load. Whereas a rod takes, a beam is which takes transverse load. Okay,
Column takes.
load perpendicular to the direct,
That is
its
length.
length. Load perpendicular to the length is transverse load, that is beam. Load along the length is called rod.
Rod.
Load applied along the length. So load along length is rod. Load perpendicular to length
Beam.
is called beam. And these members are columns. These are columns
Yes.
also. Columns take compressive load. Okay. So when this beam happens, so there will be, so this beam, there is some formula, you need not derive those formula, need not go into details of it. So just remember, like say the whole load is acting, a W is acting at the center of the beam, let us say.
Okay.
Then the deflection of the beam,
Transverse load.
because of the transverse load, this beam will deflect by an amount delta. Okay. See delta, that formula of delta is PLQ by 48 EI. Okay. That if these are just simply supported, don't get into the details of what it is and all that. It will be 48 PLQ by 48 EI. L is your length of the beam. Okay. L is your length of the beam. That means if length is more, it will deflect more.
Yeah, directly.
Also, the deflection is directly proportional to LQ. Deflection is inversely proportional to